A log equation is an equation in which the variable is contained within a log expression. We will learn two different methods for solving this type of equation. Method one is to use the one-to-one property. This method relies on us being able to have one single log on the left equaling one single log on the right, each with the same base. To use this method, all terms must be part of a log expression. The one-to-one property of log says that if the log of m base b equals the log of n base b, then m must equal n. So example number 4, we have the natural log of x plus 2 minus the natural log of 4x plus 3 equaling the natural log of 1 over x. And notice here, all of my terms in my equation are all a part of a log expression. Okay, and all of the logs are the natural log, and so they have the same base. So that's why we're going to use method 1 on this problem. And so our first step is to get one single log on the left and one single log on the right. On the right-hand side, we already have one single log. On the left, we have two logs being subtracted. If we go back to our properties from 4.3, when we subtract two logs, we can condense them into one single log by dividing their insides. So this will condense into the natural log of x plus 2 over the natural log of 4x plus 3. And that equals the natural log of 1 over x. So here we have one log on the left equaling one log on the right. And the one-to-one property says the only way that that can happen is that x plus 2 over 4x plus 3 must equal 1 over x. Okay, now our task is to solve this equation. We have a fraction equaling a fraction, so we can cross multiply. X times x plus 2 will have x times x is x squared. X times 2 is 2x, equaling 4x times 1 is 4x, and 3 times 1 is 3. So this results in a quadratic equation. We want to get all of our terms together, subtract 4x and subtract 3. So we have x squared minus 2x minus 3 equals 0. Okay, basically all of these log equation problems can be factored if you have a quadratic. Factors of minus 3 that would subtract to negative 2 would be 1 minus 3. So this factors into x plus 1 and x minus 3. And so our two possible solutions are negative 1 and positive 3. Last part of the problem, make sure you check in your original equation to see if either of these two result in a negative value inside of your log. So if I try negative 1, negative 1 plus 2 is positive 1, that's fine. 4 times negative 1 is negative 4, plus 3 is negative 1, so that's a problem. So I can eliminate negative 1. If I try 3, 3 plus 2 is 5. 4 times 3 is 12, plus 3 is 15, that's fine. And 1 over 3, positive 1/3, that's fine as well. So our solution to this problem is 3. If we're unable to rewrite our equation in the proper form to use method 1, we'll need to use method 2. Method 2 is to use the definition of the log to rewrite the equation in exponential form. So example number 5, part A, we have the log of x plus 3 base 4 equaling 2. So notice we have this 2, which is not a part of a log expression. So that's an indicator that we need to use method 2 instead. So to use method 2, we want a log on the left equaling a constant on the right. It's in that format already. So now we use the definition of a log. Remember the definition of a log, changing to an exponential. The base of the log becomes the base of the exponential. 2 changes sides to go with the 4, and x plus 3 changes sides. So it's equivalent to the exponential equation 4 squared equals x plus 3. So now solve this exponential equation. 4 squared is 16 equals x plus 3. Subtract 3, and 13 equals x. Check your solution in the original equation. If I put 13 in for x, 13 plus 3 is 16, and that does not give me a negative. So 13 is our solution. Part B, 3 natural log of 2x equals 12. So on this one we have the 12, which is not part of a log expression, and that tells me to use method 2. So first get your log alone. We need to divide 3 on both sides. 12 divided by 3 is 4. Now that it's in the correct format, use the definition of the log. Remember that the base of natural log is not written. It's an e. So the base is e. And so using the definition, the base of the log becomes the base of the exponent. And that will equal 2x. Last part of our problem, to get x alone, would be to divide by 2. So e to the 4th power divided by 2 equals x. Remember, e is 2.71, so raised to the 4th power is still positive, divided by 2 is positive. And if you substitute that in here, 2 times a positive will be positive. So this is our solution. Example 6, we have the log of x base 2 plus the log of x minus 7 base 2 equals 3. 3 is not a part of a log expression, so we're to use method 2. On the left, we have 2 logs. In order to use the definition, we need to combine this into one single log. 2 logs added together can be condensed into one single log by multiplying the inside expressions. Now that we have one single log on the left, we can use the definition. So we'll have 2 to the 3rd power equaling x times x minus 7. 2 cubed is 8 equals x times x is x squared. X times minus 7 is minus 7x. Leads us to a quadratic, so we want to subtract 8 to give x squared minus 7x minus 8. And again, basically all of these factors of negative 8 that would subtract to make negative 7, 1 minus 8. So x plus 1 will give us negative 1 as a possible solution, and x minus 8 will give us positive 8 as a possible solution. Testing these in our original equation, negative 1 in for x gives me the log of negative 1, and so that eliminates it as a possibility right away. 8, we have the log of 8, that's fine. 8 minus 7 is 1, and that's positive, so that's fine as well. So 8 is our solution to this equation.